Hello students, welcome to my YouTube channel. In this video lecture, we are going to solve questions of my random instrument landing questions. Okay, instrument landing system questions, a set of some 8-9 questions regarding instrument landing system. So this will help us revise this topic of instrument landing system, recollect important facts, and look at how questions can be asked in the exam, what can be the options, how to select the options. So let's start with question number one now. Question number one, which range facility associated with the ILS can be identified by a two-letter coded signal? Two-letter coded signal. Middle marker, outer marker, compass locator. Now the correct answer to this question is this explanation. Read it. A compass locator at the middle marker transmits Morse code for the last two letters of the localizer identifier. Okay, so the last two letters, whatever the identifier of the localizer is, okay, from that identifier, the last two letters of that identifier will be will belong to compass locator situated at the middle marker. The compass locator at the outer marker transmits the first two letters of the localizer identifier. So remember, compass located at the outer marker transmits the first two letters. The compass locator located at the middle marker transmits the last two letters. Marker beacons not combined with a compass locator don't transmit two-letter identifiers. Rather, we know that outer marker, middle marker, and inner marker transmits the Morse code, that is a continuous series of dots, alternate dots and dashes, and then continuous dashes. So the inner marker transmits a continuous series of dots, outer marker continuous series of dashes, and middle marker alternating a series of alternate dots and dashes. So the correct answer to this question will be, which range facility transmits a two-letter coded signal? So that is compass locator. If it is located with middle marker, it transmits the last two letters. If it is located with the outer marker, it transmits the first two letters. Next, which pilot action is appropriate if more than one component of an ILS is inoperative or is not functioning? So very important question. What pilot action is appropriate if more than one component of an ILS is not working in operational? Now ILS system is a precision approach aid. Okay. Now whenever any component that makes up an ILS system is not in order or is not working, then we have to increase the minimums of that ILS approach, right? So the goal of ILS approach is to get the aeroplane down to minimums as close to the runway as possible. If this ILS system is not working perfectly, meaning any component that makes up the whole ILS system is inoperative, then the minimums will have to be increased. Your aeroplane will not be able to descend as close to the ground as possible and near the runway. Increase the minimums. Now, if there are more than one component inoperative, so how will you decide your minimum? How will you increase the minimum? So out of those two components, check the minima associated with them. The component which has a higher minima will have to be selected. Okay, so any minima which is higher of the two or higher of the three components, if three are not working, the highest minima in that case will have to be selected. So use the highest minimum required by any single component. If there are two components, out of those two components, that component which requires a higher minimum, go with that minimum. That will be your minimum for that particular approach. Request another approach appropriate to the equipment that is usable. Raise the minimums a total. So you need not total or you need not add the minima. Okay. Only select that minimums which is the highest of the non-working components. So option number two of question number two, option number A is the correct option. So when components of an ILS are inoperative, higher minimums may be required, but the effect is not cumulative. So you need not add the minima. You would use the highest minimums required by the inoperative status of any single component. Is a possible choice but is not necessary. You would not add the increased minimums for each inoperative component. Okay, you would use the highest minimums required by the inoperative status of any single component. Remember that. Very important, because when you start flying in your practical day-to-day life, you will be there may be days when you will require this information, even you will require to put this information to use. So next, question number 3. Which substitution is permitted when an ILS component is inoperative? So a compass locator or precision radar may be substituted for ILS outer marker, middle marker. ADF VOR bearings which cross either the outer or middle marker sites may be substituted for these markers. DME, when located at the localizer antenna site, should be substituted for the outer or middle marker. So the correct option here is option number A. A compass locator or precision radar may be substituted for outer marker or middle marker. Okay, or outer as well as middle marker. ADF, VOR, DME, these three equipments may only substitute the outer marker, not middle marker. So remember this. That's why Bravo and Charlie are wrong. Alpha is the right, because precision radar or compass locator may substitute both outer marker and middle marker. On the other hand, ADF, VOR, and DME equipments may substitute only outer marker, not middle marker. Another important question: what facilities, if any, may be substituted for an inoperative middle marker? Okay, inoperative middle marker during an ILS approach without affecting straight-in minimums. So we have to find out of these options. You have to find that instrument or equipment which may substitute middle marker. So substitution is not necessary. Minimums don't change. Compass locator, precision radar, surveillance radar. So the correct option is option Charlie. Just now in the previous question we saw that compass locator or precision approach radar or this airport radar may substitute middle marker and outer marker, whereas ADF, VOR, and DME will only substitute outer marker, not middle marker. In this question, they have asked us about middle marker being inoperative. That's why we have selected option Charlie, which contains compass locator, precision radar, airport radar. When being radar vector for an ILS approach, at what point may you start a descent from your last assigned altitude to a lower minimum altitude if cleared for the approach? Now, whenever you are cleared for the approach, you may start your descent. You may start your descent when you are aligned with the approach course, or you are in that area, or you are more or less aligned with the approach course. So when established on a segment of a published route or instrument approach procedure, you may descend immediately to published glide slope interception altitude only after you are established on the final approach, unless informed otherwise by ATC. So correct option is option number A. Okay, option number A. Which says you may start your descent where established on a segment of a published instrument approach or route. Okay. Now, if you descend immediately, okay, if you descend immediately to a published glide slope interception altitude as soon as you are cleared for approach, that will be too early. Okay, you will find yourself below the glide path always if you do this. So if you start descending too early, you will never be able to capture glide path. Okay, your glide path will always be above you. And if you wait for too long and you start descending when you are established on the final approach like mentioned here, that will be too late. So option Bravo is too early, option Charlie is too late. The correct time is when you are established on a segment of a published route or course, you can start your descent. So option C is wrong. Next, question 6. Which of these facilities may be substituted for middle marker during a complete ILS instrument approach? Okay, so middle marker. Again, outer marker. So Outer marker may be replaced by many equipments like first ADF, VOR, okay, DME and compass locator. Middle marker may only be replaced by compass locator. Okay, so the correct option here will be middle marker. They have asked middle marker. So middle marker may be replaced by compass locator and precision radar. Next, if all IRS components are operating and the required visual references are not established, the missed approach should be initiated upon where? Okay, so your IRS system is working fine. Required visual references are not established, meaning you are not able to spot or see PAPI lights. The missed approach should be initiated at what place? At decision height on the glide slope, at middle marker, expiration of the time listed on the approach chart for missed approach. So correct option will be decision height. When you are talking about ILS, automatically decision altitude or decision height is the place where you execute missed approach procedure if you are not able to meet visual requirements or visual references, right? So option Bravo is wrong. Arrival at the middle marker, that is uh, that is not where always you find your decision height. Expiration of the time listed. Now, timed approaches are not ILS approaches. Whenever there is localizer approach, okay, such non-precision approach, you conduct a timed approach. But in case of ILS, here it's written all ILS components are working fine. So you will not execute a timed approach. So option C is therefore wrong. Next, the rate of descent required to stay on the glide slope must be increased if ground speed is decreased. Now, ground speed is decreased means your ground speed is decreased. In case of whenever there is increase in headwind. So we have done this questions in 1 in 60 rule. So whenever there is increase headwind component, your ground speed decreases, right? And whenever your ground speed decreases, the rate of descent of your aircraft increases. You will come down towards the ground at a very fast rate if you do not correct that situation. So whenever there is an increase in headwind component, as a result, the ground speed of aircraft will decrease and and the rate of descent will increase. Rate of descent will increase. Now the solution to this problem is that the pilot must decrease his rate of descent. If the pilot doesn't do anything, his rate of descent will increase because ground speed has decreased. That's why. So the pilot must decrease his rate of descent. Remember this. Okay. So the rate of descent required to stay on the glide slope must be increased if ground speed is decreased. No. You as a pilot will not increase your rate of descent. Because of decrease in ground speed, your rate of descent will already increase on its own. You have to correct that and decrease it. Will remain constant. Rate of descent will not remain constant. So option Charlie is correct. Must be decreased if ground speed is decreased. Next, which indications will a pilot receive where inner marker is installed on a front course ILS approach? Now we all know the in the Oxford book there is a table given for outer marker, middle marker, inner marker. So I'll write it here. outer marker, middle marker, and and inner marker. Outer marker, when you pass the outer marker, the light associated with it is blue. For middle marker, it is amber, and for inner marker, it is green. Correction, white. For inner marker, it is white. Next, the outer marker will transmit a series of dashes, a continuous series of dashes. Middle marker will transmit alternate dots and dashes. Inner marker will transmit a continuous series of dots. So you have to remember this, the color and the transmission. So here they have asked us information about inner marker. So inner marker, option A, 1 dot per second and amber light, that is wrong. 6 dots per second white light, yes. Alternate dashes and a blue light, that is wrong. So correct option is option bravo. So this concludes our quiz session. No, there is one more question. To remain on the ILS glide path, the rate of descent must be what? Again, similar to question number 8, it must be decreased if airspeed is increased. Okay, so when airspeed increases, maybe in a tailwind condition, so in tailwind conditions, if your ground speed will increase, and as a result, the rate of descent of your aircraft will slow down, it will decrease. To correct that situation, the pilot must increase, okay, must increase his rate of descent, not decrease. So option A is wrong. Decrease if the ground speed is increased, wrong. Increase if the ground speed is increased, yes. So this question is opposite to question number 8. In question number 8, we checked headwind. What happens in headwind? The pilot must decrease his rate of descent. Now, in this case, when your ground speed increases, let's say because of a tailwind, you will increase your rate of descent. You will do the reverse of what you did in headwind situation. So very important. Do watch 1 in 60 rule videos that I have made, questions that I have solved in. So this questions, there are a lot of questions from that chapter, and in that I have explained how to calculate this rate of descent, value of rate of descent increment, value of rate of descent decrease. Okay, so do watch that. So with this, we come to the end of this lecture. I hope you have understood all the 10 questions and you were able to solve or answer all the questions right. So I wish you all the best. Subscribe to this channel, share this video, and do hit the like button of this video lecture. Let me know your comments, doubts, questions in the comment box of this video. Don't miss my next quiz lecture. I'll see you then.